Hello everybody. Let's start this chapter area under a curve. Over here, generally in class 11 and 12, you have this kind of idea to find the area under a curve. That suppose these are two axes, x-axis and y-axis, and suppose that we have a curve, this kind of curve, hmm? Curve of a function like f of x. Okay, and the area is found in this fashion that we generally draw these two ordinates. Maybe these are the 2 points, maybe x is equal to a and x is equal to b, and then we find the area under this curve by integrating the function in between the limits a and b. So this much would be the area under this curve f of x within the ordinates x is equal to a and x is equal to b. So we generally integrate this function f, provided it is integrable. Of course, all the functions are not always integrable. But over here, this two axes, this may be the x-axis, this may be the x-axis, and this may be considered as y-axis. So x-axis and y-axis, these two axes are not always perpendicular to each other. There are some coordinate axes in which these two axes, x and y axis, are not perpendicular to each other. Sometimes they are inclined in this fashion. Say this is one axis and another is this axis, and the angle between these two axes is equal to the omega. Omega or W, whatever you call. All right. So over here, we have to study the technique by which we find the area of a function fx under two straight lines parallel to y-axis. One maybe x is, this kind of straight lines are called x is equal to a, and this is another line, maybe x is equal to b. So within these two ordinates, just similar to this figure, x is equal to a or x is equal to b. Within these two ordinates, sometimes we need to compute the area under this curve. That means this area under this curve. Okay. So what would be the formula for that area? We shall discuss this kind of results. We shall not discuss the proof of these results. Okay, we shall discuss only the formula and some application of this formula only in this chapter. And along with that, sometimes the coordinates are written in terms of polar coordinates, and so r and theta would be the coordinates, and with respect to the polar coordinates, what would be the formula for area under a particular given curve, that we shall study over here. So let us study them one by one. This portion is already known to you, but what is not known to you is that sometimes we will have two curves, this kind of curves, maybe two given curves are there. Suppose this first upper curve is the curve fx, and second curve is the curve of the function gx. Then we will have to find the area bounded by these two curves. Okay, we have to find out the area bounded by these two curves. Then it is clear that the area under the curve fx is equal to the integral from a to the limit b f of x dx. F of x dx, and the second area under the curve g, we have to remove this much area, so that we will get the area under the curve in between f of x and gx. So we'll have to subtract this much area. What would be the area? Integral from a to b g of x dx. So that would be the area under bounded by these two curves f of x and g of x, and within the ordinates x is equal to a and x is equal to b. This would be the formula to find out the area under these two curves. So this would be the formula bounded by the area under these two curves. Now, could you follow me? Is it clear to you?
Yes, sir.
Yes, sir.
Okay, so let's continue. Over here, we don't need the deduction of all these results. Okay, I was talking about the kind of curve, the area under this curve where this angle, this kind of angles, the angle in between x-axis and y-axis equal to the angle omega. Hmm. And for those angles, for those kind of curve, if this is a curve, suppose, and sometimes this curve can be written in this way. Suppose we are given, I'm writing. Let me draw this kind of curves. It would help us to understand the topic in a bit easier fashion. Now, suppose we can measure two area. One is this kind of area bounded by the curve and the axis. So this might be one area. This might be one area. Okay, and the integral for this area would be, suppose this is x, this is the point x is equal to a, and this is the point x is equal to b. Then this kind of straight lines which are parallel to y-axis, this kind of straight lines will be written as x is equal to b. Okay, and this kind of straight line, this kind of straight line, this kind of straight line will be written as x is equal to a. These are parallel to y-axis. This line, this in straight line would be written as x is equal to a. That would be parallel to y-axis. Okay, and in that case, the formula. Where is the formula? The formula is this one. The formula is this one. This integral a to b fx dx sine of omega. That would be the formula, and the detail has been written over there. You don't need all these detail. Just you need to know the formula. Generally, we have this kind of formula if we have two coordinate axes which are perpendicular to each other, like this. In that case, generally we have this kind of formula, integral from a to b fx dx. But if we have this kind of inclined axis where the angle between these two axes is equal to omega, in that case, this would be the formula, a to integral a to b fx dx sine of omega. All right. And now over here, suppose you want to find area under these two curves. Hmm? Suppose you want to find out the area, this much area. Okay, you want to find out this much area. That means the area bounded by y-axis. This was the area bounded by x-axis. This was the area bounded by x-axis. Let me delete this. In that case, hopefully, yeah, this will be a bit clear to you. All right. So this was the area under this card bounded by x-axis. This was our x-axis. And this is our y-axis. So if in place of this much area, rather if we are interested in this area, okay, in that case the integral formula would be we'll have to integrate the function with respect to y. In between the limits, suppose over here this is the straight line x is equal to c. This is the straight line. Yeah, this is the straight line, not x is equal to c, y is equal to, suppose, c. Hmm? And this is the straight line, y is equal to, suppose, d. Hmm? So in that case, you will have to integrate from y is equal to c to y is equal to d phi y dy, and then multiply this expression by sine of omega. So in this way, you will be able to compute the integral under this curve. That means this much area under the curve. Got it? So this is the technique by which you can find out the integral of this kind of curve. Hmm. So altogether, we have this kind of integration formula, and there are certain examples that has been already there. Suppose if you consider this kind of example, you will have to find out the area of the upper half of the circle. X square plus y square is equal to 25, where the ordinates are x is equal to -3 to x is equal to 4. So in between x is equal to -3 and x is equal to 4, you will have to find out the area of the circle. Is there in the picture? Yes, the picture is already there. Suppose this is the picture. Now you will have to find out the area of the upper portion. Now this, if you see over here, x square plus y square is equal to 25. X square plus y square is equal to 25. This is the equation of the circle. Then what is y? Generally, y should have this kind of value, plus or minus root over of 25. 25 minus x square. Got it? So plus sign may come, minus sign may also come. All right, but what is plus sign? Actually, positive half is actually represented by this plus symbol, and the negative half of a circle is represented by minus symbol. All right. So over here, as because we will have to find out the area under the curve, and that should be the curve on the upper portion. That's why we will have to consider this plus of root over of 25. We will have to neglect minus of root over of 25. And as you can see, in place of y over here, only plus root over of 25 has been given in place of minus. Only plus root over of 25 has been written over here. Got it? So you have to be very careful about all this portion, and remaining portion is the matter of integration that you all know the formula from 11 and 12. You all know the formula, so I'm not going to the detail of this formula. So in this way, you can find out the integral, and as per the question, the integration should be taken from -3, x is equal to -3 to x is equal to +4. Over here, it has been written that x is equal, in between x is equal to -3 and x is equal to 4. You will have to integrate this total function. So in this fashion, we can find out the area under this kind of curve. And you see over here, we can have one more example. And this says about a different kind of area, that the curve is given in this way: x square is equal to 16y. That is actually a parabola. What did he say? They say it says that find the area in the first quadrant. In the first quadrant included between the parabola x square is equal to 16y, the y-axis, and the line y is equal to y1. So this is the curve x square is equal to 16y. This is the equation. This is the curve of the parabola x square is equal to 16y. Y is equal to y1. Y is equal to some constant is actually a straight line parallel to x-axis. Okay, so y is equal to y1 would be this kind of straight line. Okay, this kind of straight line that is parallel to x-axis. So y is equal to y1 is this kind of straight line, and we will have to find out the area of this curve bounded by y-axis, not x-axis. Be very careful about it. Bounded by x-axis or y-axis, that you need to know. If it is the area bounded by x-axis, then we will have to consider this kind of area. Okay, and over here it is given that the area should be bounded by y-axis. Therefore this much shaded region is to be computed. The area of this much shaded region is to be computed over here. And over here the integration formula is y varying from this point, y is equal to this is the smallest value of the y, and over here at the point coordinate of the point is equal to 0 comma 0, the origin. So at the point 0 comma 0, the coordinate is equal to 0, y coordinate is equal to 0. So y should start from y is equal to 0, and you see at the point P or at the point Q, at both of these 2 points, the maximum value of y is y1. Got it? Therefore, we will have to integrate this from 0 to the largest possible value of y, that is y1, and x into dy should be written over here, just similar to the fashion that in place of the function, in place of the previous root, we had y into dx. Y into dx whenever the integration was performed with respect to x-axis, and now the integration is being performed with respect to this y-axis. So the formula would be just changed, interchanged. In place of x we will have y, in place of y we will have x. So x dy, this kind of formula would come. Generally, sometimes in the previous portion, this x has been written as phi of y. Is phi of y. Okay, this x over here in this working formula. Where is the working formula? I told you that yes, this x has been written as phi of y. So sometimes the expression phi of y is written, sometimes the expression simply x is written. So whatever expression you write, x phi of y or phi of y dx or simply x dx, it doesn't matter. So what you need to do in this example, over here you will have to find out the expression of x. You will have to find out the expression of x. Now what is the expression of x over here? You see, expression of x in from this expression y, x square is equal to 16y. Generally x can be written as plus or minus root over of 16y, isn't it? So x should be written as plus or minus root over of 16y. So plus minus plus expressions may appear or the minus expression may appear. But over here, if you look at this expression in the first quadrant, in the question it is given that we'll have to find out the area in the first quadrant. In the first quadrant, both x and y both are positive. Okay, so in this first quadrant you will have to consider the positive sign only. In the first quadrant you will have to consider the positive sign only. Negative sign refers to this second quadrant. In the second quadrant, y is positive, x is negative. So as because by question it is given that we'll have to find out the area under this curve in the first quadrant. So you will have to consider x is equal to positive square root of 16y. Got it? Positive square root of 16y means 4 root over of y. Now over here it is just a matter of integration. So I'll ultimately, after integration in between the limit x, y is equal to 0 to y is equal to 1, you will get this expression. So that is about the integration, simple integration technique. I'm not going to discuss this technique. So in this way we can find out the area under the curve. Got it? This kind of simple curve. In this way, we can find out the area under this curve by this kind of simple technique. Okay. Now, a little complicated cases may arise over here. Sometimes the area becomes negative. Consider this kind of example. Hmm. Generally, what we do, generally we integrate the formula. Maybe this is the equation. This is the curve of the function sine of x. In this question, hmm, it says that find the area bounded by the curve y is equal to sine of x, and the segment of x-axis from x is equal to 0 to pi, and from x is equal to 0 to twice pi. And we all know that area under this the curve of this function fx in between 0 to pi has this kind of expression. Now you see, if you find out the area of the function in between 0 to pi, y into dx by this kind of formula, starting from x is equal to 0 to x is equal to 2 pi y into dx. then just put y is equal to sine of x, you will get plus 2. So that would be the area under this kind of curve, starting from x is equal to 0 to x is equal to pi. So that would be the answer to this question number 1. Now, what about question number 2? The area of the same curve, area under the same function, but over here the limits are y is equal to pi to x is equal to pi to x is equal to twice. So in between the limit x is equal to pi to x is equal to twice pi, we will have to apply the formula on the integral y dx. And over here, if you compute this expression and just put the expression of sine of x, and you see sine of x, this function sine of x, when x is greater than pi and less than twice pi, when x is greater than pi and less than twice pi, sine of x is a negative quantity. We know that x sine of x is a negative quantity whenever x varying from pi to twice pi. That's why if you integrate this expression, you will get a negative number minus 2. So you observe that area may be negative due to the negativity of this kind of function. That's why in this question, firstly they have individually told us to find out the area in between 0 to pi and then from pi to twice pi. But if you now try to find out the entire area, one portion is positive and another portion is negative. So if you just add these two areas, you will ultimately get that the area becomes is equal to 0 in between x is equal to 0 to twice. Okay, the total area becomes is equal to 0. That may be a misleading answer to you, because you find over here that sir, area is not equal to 0. You would say that it is we can see that the total area is not equal to 0. What we are having over here, actually the positive portion of the area is cancelling the negative portion of the area. So in such cases, what we do, we generally divide the question into two parts. We take the absolute value of the area. If in your exam it is asked to find out the area under this curve, you will have to be little careful to answer this kind of question. Firstly, you will have to say that due to the fact that this curve is positive in between 0 to pi and negative in between 0 to twice pi. So we firstly find out the individual area in between x is equal to 0 to x is equal to pi, and then starting from x is equal to pi to x is equal to twice pi, we compute the second area, and the first area becomes is equal to plus 2, the second area becomes is equal to minus 2, and if we add them up, we will get the total area as equal to 0. But that would not be the exact measure of the area. In order to measure the area, we will have to consider the absolute value or the modulus value. Absolute value means modulus value. Okay. So over here, the 2-unit area, we get the 2-unit area in between x is equal to 0 to x is equal to pi, and in between x is equal to pi to twice pi, we get minus 2 unit of area whose modulus is equal to 2. So altogether we get 2 plus 2, that is equal to 4 unit of area. So in this fashion you will have to answer these questions, otherwise you will get wrong answers. Now could you follow me? Is it clear to you?
सर एक और बार बोलिए ना।
Where is your problem?
सर वो लिमिट एंड वो कर्व में।
Limit. Over
हाँ
here,
सर।
over here the limit is that if you draw this picture, you will have to identify the zone in between which the function is positive and from where to where the function is negative. If you consider this portion from x is equal to 0 to pi, the uh, the function would be positive. Okay. So in the first part, you will have to compute the area for which the function is positive. You see, in between 0 to pi, the function is positive. Okay. And in between
Okay,
pi
sir.
to twice pi, the sine function is negative. That's why we consider the limits pi to twice pi individually. One portion is computed for positive curve, another portion is computed for the negative area. And afterwards we add them up, but in addition we will have to consider their modulus value, because otherwise the positive area and the negative area will cancel each other. Got it?
Yes, sir.
Now let me show you with this example. Let me show you another curve. Suppose you consider the area of a cosine curve, not sine curve. Okay, the area, the picture of sine curve would be a bit a little different from the picture of cosine curve. Suppose this is equal to pi by 2 and this point is equal to 3 pi by 2. Got it? And in that case, this curve, cosine curve, would look like this, very close to, though it would not be perfect. Hmm. This kind of curve, it is passing through pi by 2. And yeah, let me show you through some other software. Suppose we are drawing the cosine curve, cos of x. Hmm. Let me draw the curve, plot the curve. This would be the what is the value of pi? Pi is equal to 3.14. Okay, so let me plot the curve in between the interval from 0 to 3.14 or maybe 15. Okay, so this would be the curve of the function cos of x. Let me minimize it a bit. Oh, sorry, 0 to twice pi, not pi. Sorry, 0 to twice pi. So 3.15 multiplied by 2, that means 6.3 or 6.28. Okay. So this would be the curve of cosine function in between 0 and twice pi. Now, suppose if you want to find out the area, then this much would be is equal to our pi by 2, and this much would be is equal to 3 pi by 2. This would be x is equal to 0, this is pi by 2, this is 3 pi by 2, and in between somewhere over here 3.14, this would be is equal to pi by 2. This may be our pi by 2, and this is pi. Okay, this would be our pi by 2, and this would be 3 pi by 2. 3 pi by 2, and this much would be is equal to twice pi. All right, then what you need to do in that case, you will have to consider the limit from 0 to pi by 2, integral of the function, integration from y or cos of x dx. Okay, then firstly you will have to find out the integral from 0 to pi by 2, because within this zone the function is positive. Within pi by 2 to 3 pi by 2 the function is negative, so you will have to compute the same kind of integral from pi by 2 to 3 pi by 2, and then again within 3 pi by 2 to twice pi the function would be positive. So you will have to make three integrations. One limit would be from 0 to pi by 2, second limit would be from pi by 2 to 3 pi by 2, and then the third limit would be from 3 pi by 2 to twice pi. And afterwards you will find that this much area would be is equal to plus 1, this much area would be is equal to minus 1, this much area would be is equal to again plus 1. So if you simply add them up, you will ultimately get equal to 0, because this plus 1 will cancel with this minus 1. But as because the area is a non-negative quantity, we know that area is a non-negative quantity. This negative signs comes because of the fact that the function is negative over here. This function, these functional values are all negative in this zone. That's why we get this negative sign. But what you need to do, you will have to find out the area. So you will have to add 1, then you will have to add modulus of minus 2, that is equal to plus 2. So 1 plus 2 plus this one, this area in this area of this curve 1, so that is equal to 1. So ultimately you will get is equal to 4 unit of area. In this fashion you will have to continue, otherwise you will get wrong answer. Now is it clear to you?
Yes, sir.
Okay, thank you. Let me delete this annotations. Okay, so I was talking about this kind of card. So you'll have to be a bit careful about this kind of card. Whenever positive or negative portion comes, you'll have to be a bit careful over here. And I told you that I told you about the area of this kind of circles. X square plus y square is equal to a. You can go through these examples. I am not discussing the everything. Suppose you will have to find out the area of this kind of area. You see in this question, where is the question? Area of the circle. Area say area of the region. This same circle is considered over here. Okay, this question number 4. Suppose we are considering this kind of question. What does it say? It says that find the area A bounded by the upper half of the ellipse x square by a square plus y square by b square is equal to 1. The x-axis and the ordinates x is equal to alpha and x is equal to beta. So you will have to find out the area under the curve given by the ellipse. Okay. Second part says that find also the area B bounded by the same two ordinates on the upper half of its auxiliary circle. What is auxiliary circle? Suppose this is the ellipse. Okay. And taking this major axis as the radius, if you draw one circle, then that circle is called the auxiliary circle of this ellipse. All right. And then what does it say? Show that these two areas, that means area A and the area B, the proportion of these two areas, A is to B, is free from alpha and beta. That is an important property of auxiliary circle of an ellipse, that says that A is to B. Although we will consider the integration in between A alpha and beta, but the area under the ellipse and the area under the auxiliary circle bounded by these two ordinates, x is equal to alpha and x is equal to beta, it is free. The total ratio A is to B would be free from alpha and beta. So whatever value of alpha and beta you consider, this A is to B ratio would be fixed. This ratio would always be a fixed quantity. Okay. And in computation of this ellipse, you see x square by a square plus y square by b square is equal to 1, where of course b is less than a. Let me write it over here because it is a bit comfortable for me. Suppose the area is suppose the given ellipse is x square by a square plus y square by b square is equal to 1. And in that case, generally y should have this kind of value plus minus. Y should be is equal to plus minus root over of what would be the value of y? 1 minus then x square by a square, x square by a square, and this should be multiplied by b. So plus minus b into root over of 1 minus x square by a square, that should be the expression of y. Now, what is plus sign and what is this minus sign? What is their what are their uses? Actually, what happens in case of ellipse? You see, the upper half, the area, the curve, this upper curve is represented by the plus symbol, and this lower half should be represented by minus symbol. Okay. So, as per the question, we will have to consider the area under this upper portion. That's why we will have to consider this plus symbol. Got it? So we shall consider this plus symbol over here. So the expression of y should be plus b into root over of 1 minus x square by a square. Got it? That's why you see over here in place of y, the integration is performed from the lower limit x is equal to alpha. This is the lower limit x is equal to alpha to the upper limit x is equal to beta. Okay, but integration has been performed from lower limit alpha to beta, but in place of y, they have written b by a root over of a square minus x square. That is actually the positive expression. This would be this can be written as b by a, if you take the LCM over here, then it would be written as b by a root over of a square minus x square. So we can write it in this fashion: b by a, not alpha, it should be a, b by a root over of a square minus x square. Got it? That's why in place of y, they have written this expression b by a root over of a square minus x square. And after this portion, this is actually the ordinary technique of integration, the integration that you performed in class 11 and 12 level. So I am not going to the detail of this integral formula. Okay. So this would be the area A, the area under the ellipse. Got it? And the area under the ellipse in between, suppose this is the straight line x is equal to alpha, this straight line. Suppose this is the straight line x is equal to alpha, and this is the straight line x is equal to beta. Whatever be the value of alpha and beta, you can arbitrarily choose. Now we will have to find out the area under this circle. What is the equation of the circle? You see the radius would be equal to the semi-major axis small a. Therefore, the equation of the circle would be equal to x square by a square is equal x square plus y square is equal to a square. It is written. Is it written properly? Yeah, this is over here. X square plus y square is equal to a square. This would be the equation of the auxiliary circle. Therefore, what would be y? Y is equal to positive square root of root over of a square minus a square. This is the positive square root of root over of a square minus x square. Got it? So y should be is equal to positive square root of a square minus x square, and the same integration should be performed with this lower limit alpha and the upper limit beta. So lower limit and upper limits are same, and this would be the area under these two curves. This is the area under the ellipse, and this would be the area under the circle. And now you divide both of these two expression, you will ultimately see that this area, this ratio, this a divided by b, that is simply is equal to b by a. Although these complicated expressions will cancel out, and therefore this expression is independent of alpha and beta. Got it? So this kind of questions can be selected in exam. These are very standard questions that can be selected in exam. So you please go through these questions. Today I am not discussing this portion. Okay, let me discuss this question as well, because this is an important part. Hopefully this much portion would be complete. This is a special question that you see. Over here the coordinate axis, x-axis and y-axis, they are not perpendicular to each other. The angle between these two coordinate axes, this is equal to omega, this angle. Hmm. So what does it say? It says, the question says that the find the area of the tangent, find the area of the segment cut off by the chord x is equal to, over here alpha has been given, x is equal to alpha of the parabola y square is equal to 4, sorry, of the parabola y square is equal to 4ax. Got it? And as because the we'll have to find out the total area. You see, it can be shown in case of parabola only. This result is true, that the positive portion, the area in this positive portion and area in this negative portion, both these two area become equal to each other. So we can, if we want to find out the total area, what we can do, we can forget this much part for the time being. We can firstly compute this much area, the positive portion of area, and then multiply the area by 2. Got it? Multiply the area by 2. Then we will have this kind of formula. You see, in between, uh, as per the question, in between x is equal to 0 to x is equal to a, this is our x is equal to a, this is our x is equal to a. This is the straight line, x is equal to a. Got it? In between x is equal to 0 and x is equal to a, generally the formula is integral from 0 to a, because because of the fact that x varying from 0 to maximum a. Got it? 0 to a y into sine omega dx. I told you that in the earlier part of this lecture. Let me show you. This was the where was the area? Where was the formula? Integral from a to b. This was the formula. This is this one formula, and this was another formula. Integral from a to b fx dx sine of omega. So we are applying this formula. And in place of x we have written y. In place of x we have written y over here. So let me come back to the question again. Yes, this is the question. So over here we are computing from lower limit x is equal to 0 to x is equal to a y into sine of omega. This is sine of omega dx. And as because I told you that the area in upper part and the area in lower part, both of these two area are same. One part has the positive sign, another part has the negative sign. So if you simply want to add them, you will ultimately get 0. Got it? That's why this much area, the computation of this much area has been avoided. Just we are avoiding the computation of this lower area. We can compute the upper area, and that area is to be multiplied by 2. Ultimately you will get the total area. Got it? And that's why this 2 has come. The area is multiplied by 2. Got it? And what is y? Y, as per this question, it is given that y squared is equal to 4a prime x. Alright, if y square is equal to 4a prime x, then on the upper portion, generally if y square is equal to 4a prime x, then we should get y is equal to plus minus root over of 4a prime x. Then we should get y is equal to plus minus 4a prime x. But over here, as because we are considering the upper part only, we are not considering this negative sign. We are not considering this negative sign. Rather, we shall consider only the positive sign. So y would have this kind of value. Got it? Y will have root over of 4ax, this kind of value. Clear? That's why in place of y, we have put y is equal to root over of 4a prime x, and sine of omega is constant, so 2 sine omega will remain be there, and if you integrate this expression, ultimately you will get this kind of value. Hmm? So this would be the total value of the area. So in this way you can compute the area of this kind of curve where the x-axis and y-axis are inclined with an angle omega. Omega is not equal to 90 degree over here.